Hello, everyone. Glad I have your attention, because attention is all you need these days. Very excited to be here in Istanbul, surrounded by so many innovative and smart people. I've had amazing conversation. Thank you so much for making it happen. I'm going to talk to you about solving real-world AI problems. Nowadays, at an age where we feel like we have everything in front of us, LLMs. Why is it still hard? I'm Theodosia Togia, Executive Director in Applied AI ML at JPMorgan, and all opinions I express today are my own and not those of my employer. Let's talk about the evolution of natural language processing. Now, why NLP and not AI? Well, because what we call AI nowadays is really just the evolution of natural language processing. And also, there's a second reason. I've dedicated a good chunk of my life to natural language processing, so I've seen the rapid evolution in the last 16 years that I've been in the field. So from the 50s to the 80s, something like 30 to 35 years, we had symbolic NLP, rule-based systems. Something like Eliza, that was an early chatbot. Check it out if you haven't seen it. There was also some non-symbolic things in information retrieval, like TF-IDF, extremely groundbreaking. 1990s and 2000s, again a long time. Corpus linguistics, or what we call statistical NLP, collecting probabilities from corpora to model language. It was actually called language modeling back then, trying to understand probabilities of strings. In the 2010s, a bit before I entered the field, we used to work with feature-based machine learning, things like support vector machines, conditional random fields with feature engineering. Then came word embeddings, these denser ways of representing meaning for words, and later on for strings, for sort of sequences longer than words. We have things like word-to-vec, glove, embeddings. Later on, we did sequence-to-sequence recurrent neural networks. With attention mechanisms as well. These were very applicable to things like that are sort of generative in nature, things like generation, sort of summarization, machine translation. And after that, we got to transformers that everybody has heard about. Very different architecture, but still based on attention. Later on, we moved on to contextual language models, things like Elmo and BERT and all the derivatives. These were the language models which could give a more context-aware meaning in a word, and that resulted in a lot of pre-trained models that are very easy to extend for many natural language processing tasks. And in the 2020s, we went to large language models. So the language models that started hitting like 1 billion parameters, and now it's a lot more than that. It's in the hundreds of billions. We got things like GPT-3 and all the GPTs. And the instruction-based models, the models where you could actually give them text and get back text. We had things like Flan, and then InstructGPT, and obviously ChatGPT. And I'm not going to say more about this, but I want to show you, this. Another evolution that I think is relevant, what I call the evolution of the AI industry. The graph I'm using here is actually not about AI. It's by Geoffrey Moore in 1991. It's called Crossing the Chasm, and it describes how an industry adopts new technologies. You have the innovators first. They're the people who just jump into the new technologies, not knowing what's going to happen. Then you have the visionaries, who are early adopters. Then you have a gap, and we'll talk a bit more about this. After this gap, things happen. And then you have the early majority. Most people start to adopt and get value from AI. And after that, when things really mature, you get the late majority, and AI is really established at that point. And afterwards, you get the skeptics who come very last in the game. Now, my question is, why is there a gap there? Why does it take effort to go from those early, excited adopters to those pragmatists that really want to get value out of AI, and what is sticking in between? Why is it so hard to go from one to the other? I think that's the way I see it, at least. It's very, a good analogy here is comparing going from prototype to enterprise solutions. We are right at the phase where it's so easy to create prototypes. It's a blessing. We can now create things incredibly fast. You can have people who are not, who don't have a technical background, but maybe domain experts in the problem we're trying to solve, and they can build a quick AI model. Fantastic. But going to an enterprise solution that scales, which is accepted by stakeholders, which is relevant to users, which evolves over time, it's actually really hard. And there is this bottleneck in the middle, which I think it's interesting to compare it to that chasm that stops companies from just adopting AI to really embracing it and getting the value out of it. Let me walk you through this slide, which is how I think we can build real-world AI solutions. And this looks like a waterfall, not even a waterfall. It's like a linear thing, but in practice, nothing is linear. You can imagine loops from a lot of different boxes to other boxes. But let's start with understanding the business. A lot of the time, people skip that step, which is the most important step. What do they need? Maybe efficiency, maybe revenue generation, maybe they're in a high-risk environment, they want risk reduction. What constraints do they have? Maybe they need real-time predictions. Maybe, quality doesn't matter, but they have needle in a haystack problems. Very different approaches. What are the KPIs? How are they measuring the things they want to achieve? AI should absolutely care about this. If AI does not push those KPIs, we're doing something wrong. What integrations I may need to do? Maybe there are legacy systems. Maybe the integration I depend on is not going to happen, so I need to sort of go back to the drawing board. And who are the users? And what do they do? Okay, so building a team. Who gets to build that solution? We need cross-functional teams. We need something like AI, data science, however you want to call it, something like engineering, data engineering, MLOps, whatever, something like product or project management, very often, and 100%, absolutely, we need domain experts. Don't skip that step. Org structure. These different teams, where do they sit organizationally? Are they even aligned? Are they trying to achieve the same thing? Another thing, upskilling. And I'm going to mention the kind of upskilling that most people don't think about. Upskilling technical teams. Are my data scientists comfortable with writing production code? I don't want to see any more Jupyter notebooks. Are my data scientists and engineers able to talk to domain experts in their own language? Are my engineers able to work with data scientists and understand their methodology? For example, AI evaluation is not the same as testing in software. And team structure, do I have the right structure, communication channels, and all of that? Now, designing an end-to-end AI solution, what are my SLAs? Maybe we have low latency problems. That constrains the algorithms I should be using and actually the end-to-end architecture. Maybe I have other constraints, like cost, for example. Infrastructure. Can my current infrastructure support what I want? Maybe I want an on-prem, off-prem communication. Data pipes, ingestion, maybe streaming, maybe batch ingestion. I may have feedback loops, which I probably should have if possible. What class of AI models am I going to use? Because that will affect the architecture. Now let's talk about data preparation. Can I access the data I want? And can I use it in the way that I want to use it? It's a big topic that will take a while to explain, but it's important to get to that early. How structured is my data? Do I have enough? is it good quality? And that's another big topic. Roughly what kind of subsets of data will I have to use as features? And how complex is my data? For example, conversations or things like sensor readings or genomic data can be really, really complex data sets. I need to think about this early. And what is the distribution of my data? Is my data imbalanced, for example? Is the data distribution changing over time because it's a live system where people sort of keep adding kind of use cases that sort of look the same, but the data distribution keeps changing? What do I do in these cases? Now let's go and build the AI model. What architectures do I need? So many options out there. The only thing I want to mention here is LLMs are great. They are not the best in everything. There are cases where LLMs are actually not the best performing, no matter how hard you push them. How about zero or few shot models? What do we do in this case? If that's an LLM solution or another sort of language model or any other model, how do I organize that? And if I'm going to need any fine-tuning, how do I do it depending on the kind of model that I have? Tracking, things like data, code, any configs like hyperparameters, my actual models versioned. All of this needs to be tracked for reproducibility and obviously audit purposes. Constraints, again, you have a latency constraint, that constrains your AI models. Or you need to be quick to market, you need to be careful about what models you pick. Evaluation. Methodology, maybe quantitative, maybe qualitative is what you're after. Maybe you need some kind of downstream sort of A/B testing kind of thing before going live. Do you have environments that can host prod data so you can evaluate with real data? What metrics do you use? It's not just accuracy, it's a lot of things. If you have, say, ranking kind of output, you need ranking kind of metrics. If you have imbalanced data set, you need to think about your metrics. Maybe some metrics matter more than others. In some problems, recall is everything you need to be optimizing. In others, maybe precision. Business KPIs. Again, AI should be pushing those in the direction they should go. Baselines. And do the business needs change? So what do I do in that case? Going live. Governance. Just a bullet point here, but quite a process, especially in regulated environments. It's there for a good reason, though. Operational testing, getting users to test in the real environment, and getting the stakeholders to finally seal it and sign it off. And then improving the model and monitoring over time. Feedback loops. One thing I will mention quickly is user experience really matters when you collect feedback. What assumptions are people making when they change or don't change an AI prediction? Did they not change it because it doesn't matter for their user experience? In which case, what do I conclude from this? Detecting data drift as well, and audit trail again, capturing everything that can be captured to reproduce entire pipelines. And AI performance, one is measuring AI performance, and the other one is also improving performance over time. And if this needs to be done in real time or close to real time, there are other considerations. Now take all of this, add all the loops that are not on the slide deck, because sometimes maybe you prepare the data and you realize, oh my God, this is not gonna work. Let me go back to the business and ask something, or let me go back and get some data experts, so build a new team. So it's quite an iterative process. And also you need to constantly unblock people, make things happen, do governance and all this fun stuff, and reprioritize if needed. I will finish by saying this. Nowadays, building AI prototypes is incredibly fast. We're really blessed that we can see what AI can do very, very, very easily nowadays. But it's also today that we need to build real-world AI systems, and we need to learn at an organizational level how to make it happen. Thank you very much.
Thank you, actually.